Good morning, my dear students. In this video presentation again, we will discuss some more problems meant for students of class 12 of CBSE. I'll just move on to the problem directly. The first problem meant for today, it goes like this. If modulus A vector equal to 3, modulus B vector equal to 4, and if A vector plus lambda times B vector is orthogonal perpendicular, both will imply the same meaning. A vector plus lambda B vector is orthogonal or perpendicular to A vector minus lambda times B vector. Find lambda. This is the question. Just read the question if you want. This I'll show it to you for a minute. Okay, the condition for two vectors to be perpendicular is A dot B is equal to 0. Now, A plus lambda B is perpendicular or orthogonal to A vector minus lambda times B vector. This is what is given to you, which will imply I mean to say A plus lambda B dot A minus lambda B is equal to 0. If two non-zero vectors A vector B vector are given, A dot B is equal to 0 will imply mod A into mod B into cos theta is 0, which will automatically imply mod A equal to 0, mod B equal to 0, cos theta equal to 0. Theta is the angle between the directions of the vectors. If they are non-zero, mod A equal to 0 is meaningless, mod B equal to 0 is meaningless. Therefore, only possibility is cos theta is equal to 0, implies theta is 90 degrees. Therefore, they both will be perpendicular or orthogonal. Therefore, two non-zero vectors are perpendicular or orthogonal if and only if angle between them is if and only if A dot B is equal to 0. I repeat, two non-zero vectors A vector B vector are orthogonal or perpendicular if and only if A dot B is equal to 0. If A dot B is 0, they are perpendicular. They are perpendicular, A dot B will be 0. Therefore, let me just apply distributive property. This is minus sign. I mean to say A dot A minus lambda times A dot B plus lambda times B dot A minus lambda square B dot B is equal to 0. This is the application. These two will get cancelled because A dot B is equal to B dot A. Here I end up with mod A square minus lambda square mod B square is equal to 0, which will imply mod A square is equal to lambda square mod B square, which will imply lambda square equal to mod A square by mod B square, which will be is equal to 9 by 16, which implies lambda is equal to plus or minus 3 by 4. I can have negative value also. I should write plus or minus 3 by 4. If anybody writes only 3 by 4 or only minus 3 by 4, it is not correct. Let me just repeat. A vector plus lambda times B vector is perpendicular or orthogonal. If the question uses orthogonal, this is O, this letter is O. Okay, this is O, remember carefully. Orthogonal to A vector minus lambda times B vector, then A plus lambda B dot A minus lambda B is 0. Let me apply distributive property. A dot A minus lambda times A dot B plus lambda times B dot A minus lambda square B dot B is equal to 0. But A dot B is the same as B dot A, therefore plus minus will get cancelled. A dot A is mod A square, mod A into cos 0. B dot B is mod B square. Therefore mod A square is lambda square mod B square. Lambda square is mod A square by mod B square. Mod A is 3, mod A square is 9. Mod B is 4, mod B square is 16. Therefore value of lambda happens to be plus or minus 3 by 4. Value of lambda happens to be plus or minus 3 by 4. It's not a difficult problem. It's easy to follow. Just apply distributive property of dot product. It will get you the answer. Don't forget to write plus or minus at the end. If you don't write plus or minus, you may lose marks at the end. Next sum. If A is equal to set containing 1, 2, 3, numbers 1, 2, 3. Relation R on A is such that capital R equal to 1, 1, 2, 3, 1, 2. Find the minimum number of ordered pairs to be added to R to make it transitive comma reflexive. This is the question. Just see. This is the question. Okay, now just see here. A has elements 1, 2, 3. A has elements 1, 2, 3. R on A is such that, okay, R has elements. What are they? The elements given here are 1, 1, 2, 3 and 1, 2. Okay, just listen carefully. For it to be reflexive, okay, by reflexive nature, each element should be related to itself. I should have 2, 2, 3, 3. We should have 2, 2, 3, 3 element of R. Okay, then 1, 2, 2, 3 is there, implies 1, 3 should be there in R. Then only it will be transitive. Therefore, minimum number of elements to be added with R to make it transitive and reflexive, or what are they? 2, 2, 3, 3 and 1, 3. These are the 3 elements to be added for the whole relation to be reflexive as well as transitive. It is not a difficult task to follow. 2 should be related to 2, 3 should be related to 3, 1, 1 is already there. Therefore, these are to be added, these 2 are to be added for it to be reflexive. Already 1, 2, 2, 3 is there, therefore 1, 3 should be there for it to be transitive, otherwise it won't be transitive. Therefore, for the relation to be reflexive as well as transitive, the minimum number of elements we are supposed to add will be definitely 2, 2, 3, 3 and 1, 3. It's not a difficult task. Then next one is evaluate integral 0 to pi x tan x dx by secant x cosecant x. This is the question, just see. This is the question. Let me just see what happens here. Let me just find out what happens. Just see here. Let me rub this off and then proceed. Integral 0 to pi. It's not a difficult sum. Just see how we go about it. I call it as I is equal to integral 0 to pi x tan x dx by secant x cosecant x. Also I is equal to integral 0 to pi minus x tan pi minus x dx by secant pi minus x then cosecant pi minus x. So the rule behind this is 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Instead of a I have pi. Let me just simplify further. 0 to pi minus x, I call it as 1. Here I'll end up with minus tan x dx. Then here it is minus secant x. Here it is plus cosecant x. The second quadrant cosecant is positive. Therefore, I will be is equal to 0 to pi minus x tan x dx divided by secant x cosecant x. Let me just add 1 and 2. LHS is 2i. RHS I'll be able to add x plus pi minus x times tan x dx by secant x cosecant x. This x will anyway get cancelled. I is equal to pi by 2 integral 0 to pi. I will write this as sin x by cos x into 1 by cos x. This cosecant will go up sin x dx. This cos x gets cancelled. Pi by 2 integral sin square x dx 0 to pi pi by 2 integral 0 to pi 1 minus cos 2x by 2 dx, which is pi by 4 integral dx 0 to pi minus pi by 4 integral 0 to pi cos 2x dx, which is pi by 4 ex 0 to pi minus pi by 4. This will be sin 2x by 2 0 to pi. This will end up with pi by 4 into pi minus pi by 4 into sin pi is also 0, sin 0 is also 0. So my final answer happens to be pi square by 4. My final answer will be pi square by 4. Let me just repeat the whole process. This is my I assume it to be 1. Also I equal 0 to pi, pi minus x tan pi minus x dx by secant pi minus x cosecant pi minus x. The reason behind this is 0 to a f of x dx, 0 to f of a minus x dx. Instead of a I have pi, instead of f of x I have this much except dx. Can be written as 0 to pi, pi minus x, tan pi minus x. Tan is negative in the second quadrant, therefore it becomes minus tan x. Secant is negative in the second quadrant, minus secant x. Cosecant is positive in the second quadrant, plus cosecant x is minus minus, I make it as plus. If I add both 1 and 2, I'll have a common denominator, I can add the numerator. Therefore I'll have x plus pi minus x will make x getting cancelled. Bring this 2 down. I is pi by 2 integral 0 to pi. Tan x can be written as sin x by cos x. Secant x can be written as 1 by cos x. Cosecant x taken to the numerator becomes sin x. Sin square x can be written as 1 minus cos 2x by 2. Make it into two integrals. Pi by 4 0 to pi dx minus pi by 4 integral 0 to pi cos 2x dx. Pi by 4 x 0 to pi minus pi by 4 sin 2x by 2 0 to pi. Now pi minus 0 is your reduction here. Therefore it becomes pi square by 4. Sin 2 pi is 0, sin 0 is also 0. Therefore my final answer gets reduced to pi square by 4. Final answer gets reduced to pi square by 4. Pi square by 4. Rest we'll discuss in the next video. I'll check for the answers as usual. If there is any correction, I'll add up. Otherwise, I'll upload as it is. Thank you students for patient watching.